Hello, and welcome to the Six Figure Developer Podcast, the podcast where we talk about new and exciting technologies, professional development, clean code, career advancement, and more. I'm John Calloway.
I'm Clayton Hunt.
And I'm John Ash.
With us today is Anthony Chu. Anthony is a cloud developer advocate at Microsoft in Vancouver, Canada. He's been a software developer and architect for almost 2 decades, currently focusing on serverless, containers, JavaScript, and .NET. At Microsoft, Anthony is helping make Azure an awesome place for developers to deploy their apps in any language and platform. Welcome, Anthony.
Thanks for having me.
So before we get started, I think on Azure Functions, what we've been talking about, would you just maybe give us a little bit of background about yourself, kind of maybe how you got started in the industry?
Sure, yeah. So I took a pretty traditional path. I went to the university here in Vancouver, UBC, and did computer science for 4 years, actually 5 years, because I did the co-op/internship program. And then I kind of came out to the world, and it was right at the top of the .com bubble. And I joined a startup, and then that didn't last too long, but I met a ton of great people there. And then sadly, the place kind of closed down. And then I was kind of looking around for a job, and then I ended up at a forestry company here in Vancouver. Forestry is a fairly big industry here in British Columbia. So I was very fortunate to end up there. And then I kind of stayed there for maybe a little too long, 11 years, until I finally got out, and I joined a startup, a kind of a consulting firm that was only about 6 people big. Did that for about 18 months, and then I went to a slightly bigger startup, about 200 people, and it was an e-commerce company, and I got to be a software developer and then eventually a software architect there, until I joined Microsoft a couple of years ago as a cloud developer advocate. And now I do something totally different. No longer sitting behind a desk and coding, and going out and talking to people about software in general. Focusing on JavaScript and .NET and serverless and containers, and then spending half my time taking that feedback back to the product teams to try to make Azure the best place to deploy software.
Very cool. Very cool. So let's talk about Azure Functions. Maybe before we get started, would you just sort of give a basic introduction to what they are?
Yeah, so Azure Functions is, I guess, the flagship serverless product that we have in Microsoft Azure. And I guess we should probably talk about what serverless is first. Serverless is typically defined by 3 kind of main properties. One is that obviously there's no servers. And that's not totally true. Somewhere there's still servers, but I guess we think of it as less servers. So you normally don't think about servers when you work with serverless. And then another thing that typically you get with a serverless platform is that you get infinite event-driven scaling. So you would just have something that's supposed to react to an event. And we make sure that when one of those events occur, or 1,000 of them happen at the same time, that your code that's supposed to respond to this event will be executed. And then the third one is that you get micro billing. So you only pay for what you use, and you pay like fractions and fractions of a penny per execution. So it's very cost efficient, especially if you're getting started. And you don't really want to, pay for servers and deploy your applications there. You literally can just deploy little functions, and they don't cost you anything if they don't run, and you only pay when they get run.
Okay, so I guess what are the problem areas that the serverless really tends to shine in solving?
There's probably quite a few areas. One is that it really allows developers to focus on their code, on the kind of like the business problem they try to solve. So typically when we try to deploy, traditionally in our application, if we want to deploy that to something like as an ASP.NET app to a server somewhere, you have to manage the OS, you have to manage, in the case of .NET, you have to make sure that there's IIS running, and you can deploy your application there. And then after you've done all that, then you're writing your code. And typically the code that you're writing is still, an ASP.NET application or a Node Express application. So to kind of like configure all the middleware, all that stuff. what you really want is to write that very last piece of code that runs when you get an HTTP event, or when something happens in a queue or something like that. So serverless allows you to just focus on writing that very last piece of code, and we make sure that that's being run. And I kind of forgot about the other thing that I was going to talk about, but we'll move on, and then
Okay.
we'll pick it back up.
I guess maybe a better way to kind of come at this would be what are the areas that it's not going to be a good fit for? Is there a particular type of problem that why wouldn't you just do always serverless for everything?
So there's a few, like if something that you have if it's a process or workload that takes quite a while, serverless is good at very, very small workloads, things that happen in seconds or milliseconds. When you start talking about something that takes minutes, maybe hours, like a batch job, there's probably different ways of doing that. And as well as things that are kind of pretty constant in kind of request rate. So for instance, if something doesn't really change, like for instance, you always get a certain number of messages in the queue, and you kind of want to just keep processing it. It might be more worthwhile to just host that thing on a server and have it to queue these messages. Or if you have like a constant rate of getting these HTTP requests, that you might just want to have an ASP.NET or a Node application that responds to these requests. Where serverless really shines, and that was where I wanted to go in the first place, is that if you have workloads that are pretty spiky, so sometimes nothing happens, and then the next minute a lot of things happen, that's where serverless really shines, because you don't have to worry about having the infrastructure in place. Even if you're using platform as a service, typically you would want to set up like auto scaling on your servers to make sure they scale out, and that's typically fairly slow and reactive. Whereas serverless, especially if you would respond to things like queue messages, for example, the platform can actually monitor how many messages there are in the queue, and it can really see when it's falling behind in processing the queue messages, and it'll just massively scale up for you until it catches up.
That's pretty cool.
One of the things that you said just now, explaining a function, was that there are for processes that don't take very long, something that's really, really fast to execute. Something I've been hearing about lately has been durable functions, and I don't quite understand them. I don't understand the distinction between choosing a durable function versus like just having a server with a web API on it. Can you where is that dividing line?
Yeah, maybe we can kind of step back a little bit and talk about what typically happens in a long-running workload. Typically, it's like a batch job that has to hit a bunch of APIs or databases to pull back a bunch of records, and kind of have to massage the data in memory and then maybe ETL it somewhere else. Typically, what you can do in most of these cases is you can have a function. You can kind of break this up into multiple functions, and you can break it up into a function that gets all the database records, for example, that you need to work on, and then basically turns them into queue messages. And that allows another function to massively scale out and work on these things, so you don't have to kind of work on them sequentially. And then you can have the results saved somewhere else, or kind of carry on and have it call other functions until your work is done. That's typically how you get around a longer running application and kind of fit it into a serverless world. And durable functions kind of helps you with that, because typically, even as I just described it to you there, it's a lot of taking some data here and then kind of changing them into like the queue messages, and then making sure that there's another function set up that'll listen to these queue messages and kind of orchestrate all the different things that happen in the different functions until you get the end results you want. And durable functions allows you to create this function that's an orchestrator that calls out to different functions. So for instance, an orchestrator, in the case that I just kind of described there, can first invoke a function that will do nothing else but pull back a bunch of database records. And then in the next step, it can go ahead and take these database records and call maybe like a data processing function repeatedly with it and kind of parallelize that. And then maybe we need to take all those results and fan them back in and actually do some kind of a map reduce kind of a scenario. And that's typically kind of hard to do when you're just managing queues and these things. It's not that hard to fan out, but fanning back in, knowing when things are done, that's difficult, and kind of coordinating between all the different functions that you've kind of fired off. So durable functions allows you to write pretty much this imperative code that allows you to get other functions to do work and coordinate between them so that you can get the results you want. And it can actually be things that never end. You can imagine a function that basically has an infinite while loop that, be every day it goes and checks something, it does something, and then it just goes to sleep for another, about 24 hours, wakes up again, does more stuff, and can eternally do that. That's another pattern that you can implement with durable functions as well. And the difference between that and a long-running function is that you don't pay for the times when you're just waiting around for stuff. So for instance, if the durable function starts, or the orchestrator starts, the first thing that it does is it's going to go out and call another function, or maybe it'll wait. When it's calling another function, or it's waiting, or when it's just kind of like waiting for like a timer, you don't pay for that. And the platform will make sure that the other function runs, get the results, and then when it has all the results that it needs to kind of carry on to the next step, that's when it kind of rehydrates the function and runs it. So so you don't pay for, even if the orchestrator runs a day, a week, forever, you don't have to pay for that except for the milliseconds that it's actually executing to coordinate all these other work.
Okay, that's interesting. Whereas like with a normal function, if you put a sleep in it, you got to pay for the sleep, right?
Yeah, and you're still subject to the 5 or 10 minute kind of timeout that the platform imposes on you.
Okay.
Yeah, I've been working a lot with functions on my current project, my latest project. So really enjoying the latest V2 release. I think that was not quite a year ago, but last time I had played with Azure Functions was a little over a year ago, and still struggling with the V1 release. So it sounds like there's a lot more support for different languages and different configurations and different ways to deploy these. Has that come a long way? Is there still a long way to go?
Yeah, I think it's come a long way. So it's always had a pretty good support for both .NET-based languages like C# and as well as JavaScript and TypeScript. But over the last year, we've kind of come out with Java for Azure Functions, which is totally new, as well as support for Python and even PowerShell. So we're slowly kind of picking up new languages. We kind of have a Go kind of language worker that's in private preview right now. We're not really sure what we're going to do with it. But as kind of demand for new languages come along, we're going to look at new languages to support. Yeah, and the and just the way that Azure Functions is implemented, creating support for a new language is, I wouldn't say as easy as creating a new language worker, but you basically just have to implement a language worker using the language worker spec, and all it does is that whenever something happens in the Azure Function side, the runtime will just send messages over gRPC to your language worker that actually does the work in the language that you want, and then returns the results. So it's a pretty kind of elegant implementation, and it allows the functions, no matter what language that you're using, to have access to things like bindings, for example, which we haven't really talked about yet. So you can really talk to any kind of data source or queue without actually using any SDKs or APIs. Yeah,
the functions I've been working with here recently are really more or less just responding to event grid events, and when a blob gets added to storage, we're responding to the events, wrapping URLs to the blob itself in a SAS token, and then refiring that events to different subscribers on hybrid connections. So is that a typical use case, or people what are people using functions for if not for responding to events or doing things differently? What are other use cases?
I think we get a lot of people using them for HTTP because we make it so easy for functions. Pretty much any function that you have can be an HTTP function. So it's pretty easy to build a REST API with it if that's what you want to do with your functions. So we see a lot of people using HTTP, as well as all the stuff that you just mentioned, responding to messages on a queue or responding to event grid events, which are actually just HTTP webhooks. To things like the Cosmos DB change feed, so you can actually have functions that react to changes in your database. So we see a lot of that in the kind of like the pure kind of functions kind of world. But with things like durable functions, that even opens up a lot more doors in terms of different ways you can program. Yeah, you're no longer kind of just thinking about, how do I write a function that does something and return a value? You're now orchestrating across different functions. And even in the durable function stack, we recently announced that we're going to support kind of like serverless actors. So instead of, if you kind of think of functions as kind of like the simplest programming model that you can have, we're now looking at supporting different programming models, like we talked about orchestrators with durable functions. And what we can also now do serverless actors if you're into using actor frameworks to really abstract a lot of highly parallelized work into some really simple classes and functions, so that you don't have to worry about concurrency. You just kind of write the code, and you can scale massively. And that's really popular in the IoT world and stuff like that.
Okay, so I had heard that talk about being able to take functions and taking them sort of beyond their serverless and maybe run them on dedicated infrastructure or like Kubernetes or something like that. Would you talk about that? Maybe why someone would want to do that, or why not?
Yeah, so typically, at least me personally, I would not recommend that anyone start with anything other than what we call the consumption plan, which is kind of what we just talked about. So you only pay for what you use, and we manage all the infrastructure for you. That typically is, I would say, valid for 90% of the use cases. Quite often, when you have, for instance, like we talked about a little bit earlier about things that kind of have a very kind of stable rate at which they occur. So maybe just always constantly processing queue messages. You might actually hit a point where it's cheaper to just run them on dedicated servers. Mm-hmm. And sometimes, for instance, you might already have some Azure app service instances out there where you're deploying your web apps. So you can actually deploy functions to those existing app service plans that you already have. So instead of paying more, even though they're like fractions of a penny, you can just run your functions directly on your existing app service plans. That saves money, and you don't have to worry about managing more infrastructure. Although I guess there's not really any more infrastructure to manage. And because functions is it's both a programming model and a way of running it. That's kind of and those are kind of separated. So with the programming model, you can choose your language, you can choose kind of the bindings that you want to work with. But you also have this other piece, which is where the actual runtime or the functions actually run. So we allow you to choose between the consumption plan, which we say most people should be running on, but we also give you the option of running it in things like app service plans, and more recently on things like Kubernetes, which is super exciting because it's traditionally quite difficult to run event-based serverless things on something like a Kubernetes cluster, because typically what functions need to do, or even serverless workflows need to do, is that when nothing's happening, you really want them to scale down to zero. You don't want them to take up any compute resources at all, even if it's just memory. So traditionally, like in Kubernetes, the autoscaler will scale something from say 1 to as many instances as you said as the max, but it won't scale down to 0. So we spent a lot of time kind of thinking about how do we solve this. In Azure, we solve this by something that we hide from you called a scale controller. that actually goes off and monitors the queues and the HTTP events and all these other things on behalf of the functions. So when a function doesn't actually, get any executions, we can actually put that to sleep and just basically just stop running it. So effectively scaling it down to 0. But we still have this other piece, the scale controller, that kind of runs centrally for pretty much all the function apps that it manages. And it still goes off and starts, keeps checking blob, keeps checking the queues until something happens, and then it will go off and start scaling up your function app from 0 again. So that piece, like we already have in the cloud for a few years. What we've done is we kind of rewrote it in Go and brought that over to the Kubernetes world as a project that we're calling KEDA, K-E-D-A. And that's essentially the piece that allows Kubernetes to scale something down to 0, and also scale it back to 1 and beyond as events happen. So it's a pretty kind of cool piece of tech that we created, and we kind of created it in cooperation with Red Hat. So not only are we supporting things like Azure Functions, basically anything that needs to respond to events in a Kubernetes cluster can potentially use KEDA. So for instance, we already have adapters for Kafka and RabbitMQ. So these are things that have nothing to do with Azure. And you don't even have to write Azure Functions. You can just think of any container that has a little process in there that maybe dequeues some messages off of a RabbitMQ topic, and it can just run. But then after a while, maybe nothing's happening. KEDA can actually scale that container down to 0, and then when it sees that there's messages in that topic again, it'll just automatically scale that deployment back up to 1, and then up to whatever instances it needs in order to keep up with these messages. So you kind of get the serverlessness of serverless compute without actually running it on someone else's platform. You can run it on your own. And what we're finding is that a lot of people are standardizing on Kubernetes, but they still want to offer the developers the ease of use of something like Azure Functions. And this kind of gives them kind of like the best of both worlds. So we're seeing a lot of interest in that, both with KEDA working with Azure Functions, as well as people contributing other adapters. So I believe there's things for, I think SQS in Amazon. I believe you can listen to stuff from Google Cloud as well. So there's been more and more adapters being added to the KEDA project, so that it can pretty much be the thing that the event-driven scaling tool for Kubernetes.
So you're talking about the being able to run some of this on your own platforms. Makes me think of some of the other things that I've kind of heard people talk about. What have been some of the sort of misconceptions that you've run into that kind of keep people from moving in the direction of serverless, where they would probably benefit a lot from it, but they just sort of have some idea that sort of kind of keeps them from feeling like maybe they're going to have to run it on someone else's platform. Difficulty testing, the code ahead of time. What are some of those misconceptions?
I would say that there's probably a lot of misconceptions, but I think a lot of the blockers for actually using serverless aren't there anymore. So you mentioned things like vendor lock-in. With things like KEDA, there's a little bit less of that now. Obviously, if you write your functions to use Azure infrastructure, for instance, listen to the blob storage and queues, in a sense, you're still kind of tied into the platform. To me, I think that's okay for a lot of people, because with that, you don't have to manage anything yourself, like RabbitMQ and things like that. So you can move a lot faster. But some people do want to kind of run their own infrastructure and have nothing to do with the underlying platform that they're running on. So things like KEDA and just the ability to run Azure Functions in a container on Kubernetes or some other container orchestrator really helps with that. And I think, to me, I think most of the time, that I think there are true blockers to people getting onto serverless is still just the lack of knowledge of what serverless is able to do, and kind of like the perception that perhaps it's a huge learning curve, which I think in the past it might have been, and things like being able to run it locally and debug it locally. I think for the most part that's solved on pretty much all the platforms. Like for Azure Functions, our entire stack is open source, so we have really good integration with Visual Studio and Visual Studio Code. So to create a Azure Functions project and actually do something useful, you can get going in a few minutes. And then when you run the application locally on your computer, it's the exact same runtime as we use in the cloud. So you have a pretty good idea that it's going to work. Obviously, you're typically running it on, for instance, like for me, like I'm working on a Mac, so when I deploy it, it'd be to Windows or Linux. So there might still be some slight differences, but you know that the runtime that you're running on, and pretty much everything above that, is it's consistent with what you're getting in the cloud.
Cool.
So along those lines, if people are looking to get started with Azure Functions or just kind of jumping off the deep end and wading into the realm and getting familiar with these things that are just moving so very quickly, are there any best practices? How does one get started and make sure that you don't get started in the wrong direction?
I think that the best way to get started is find something really small that, like maybe, for instance, you have this new requirement that, I need to run something that processes a report that I email out at midnight every night, right? So the options are typically to maybe to hack this into an existing application that you already have, maybe an ASP.NET application using Hangfire or something, or you would set up a VM and just run some kind of like a scheduler or something on there. That's a good opportunity to see whether or not you can do something like that with Azure Functions. Typically, the function that you're writing is exactly the same code that you would write when you're writing something that would do this, either as part of another application or a brand new console app that does this. You can bring in the same libraries that you typically want to use, and kind of do the things that you need to use, that you need to do. And potentially, it's even easier. Because you don't have to worry about, for instance, sending an email. You could go and figure out how to, talk to an SMTP server or whatever. But Azure Functions actually has a SendGrid binding that allows you to just return an object that describes who your email is going to, the subject and the body. And behind the scenes, it goes off and talks to SendGrid to make sure that the email is sent in the way that you want it, with the right template and stuff like that. So that makes things a lot easier. Something that typically takes tens of lines now takes 1 or 2 lines. So that's a good way to get started, I would say. Or just like small kind of HTTP kind of APIs. Like I wish I had an HTTP endpoint that does this, this one little thing. That's a good time to try Azure Functions as well.
So what's next with serverless? Is there anything coming up that's exciting that we should hear about?
Because everything is open source, there's not too much we're hiding from you. So as far as like, I would love to see more programming models. Like I was saying, like I think functions really is just the simplest programming model that serverless could have invented for the space. And then, like I was saying, we're slowly moving towards being able to orchestrate different functions, and kind of like making sure that the different functions can work together nicely with things like durable functions, as well as serverless actors. So I hope that we can find other kind of things, like the other different kinds of programming models out there, and maybe we can implement those serverlessly as well. And we're also doing things like traditionally because serverless executes really quickly and then kind of just goes away. We're finding it difficult to do things like how do you maintain a long-running WebSocket connection so that a function can push messages down to a bunch of connected clients. So we're solving that with a service called Azure Signal Service, with a binding from Azure Functions. So literally, you return an object that just describes who your message needs to go to, And then it goes off and uses Azure Signal service to send messages to a bunch of connected clients. So the clients are actually connected to Signal service. And if you're from the .NET space, you'll kind of know what Signal is all about. And if you're not from the .NET space, you can kind of think of it as just something like Socket.io in Node, where it's a higher level protocol that includes, or it's a higher level programming model that you can use to kind of build real-time applications. And then behind the scenes is using things like WebSockets, long polling, and server-sent events to make sure that you get push messages to all your clients that are connected. So we're kind of investigating. We're kind of like moving in those directions where typically serverless hasn't been great for. In this case, maintaining a long-lasting, persistent connection like a WebSocket. And working together with other Azure services so that we can make these scenarios possible.
Okay, that sounds good. To go in another direction, one of the things we have all of our guests on, we ask everyone if they would speak to our listeners that are just getting started. Maybe people have been just have briefly been in, begun their careers and they're looking to kind of level up. What kind of words of wisdom, piece of advice would you speak directly to those people?
I would say one piece of advice is like every year, maybe every 6 months, really like spend the time to evaluate where you are in your career, how things have gone in the past 6 months or a year, and where you want to go in the next maybe year or 2 or 3. And really come up with a plan to figure out where you want to be. So I mentioned earlier that I was at the forestry company for maybe a little bit too long, for 11 years. And that's, in a sense, it was all because like there was other things going on in my life, like getting married and having kids, getting a house and stuff like that. But I just really didn't think a lot about my career. So I kind of wish that I thought about it more, so that maybe I would have just done the same thing and kind of just stayed there for 11 years anyway. But at least I would have had, felt like I would have more control or be more aware of where I am in my career. So I would say that's kind of out of all the stuff I could say, that's probably one of the ones that maybe I wish I could do a little bit better at. Because what ended up happening for me is that eventually I did realize that, maybe, I do want to get out of this place and maybe try something new. And because I was there for so long that I didn't really have a lot of relevant skills. So at that point, it actually took about 2 or 3 years of me spending about 2 hours a night to kind of skill up. And before I could go and find another job and try something different. So if I had done that a little bit earlier and kind of realized that I'm falling behind, maybe I would have kind of been keeping up a little bit better than spending 2 hours a night for 2 years to catch up.
But that's cool though. How about resources that you might point people to who are looking to get into get started or looking to get into Azure Functions and they're trying to learn?
I think the best place to start is docs.microsoft.com. We try to make sure that we have all the documentation, samples, and tutorials in there to get anyone started, or to like even if you've kind of been working on it for maybe a year, to go there and be your source of truth for all the information. And then as a kind of like an offshoot to docs.microsoft.com, we have a kind of fairly new thing called Microsoft Learn. And you can get there from docs.microsoft.com as well, where without even having an Azure account, you can just log in, I believe, like a Microsoft account or something like that. And we give you a sandbox and a tutorial with all the steps that you need to take to walk through and actually complete a task. Things like building an Azure Functions app. I was involved in one for it's a Learn module for how do you get started with Azure Functions and Azure Signal service to change an existing app that keeps pulling a database to one that responds to changes in the database and just pushes out the results to a web page. So yeah, so I would definitely check that out, especially that one, and because I wrote it, and or I helped write it, and yeah, like I'm happy to share those links if you have show notes.
Yeah.
Yeah, that would be appreciated. I hadn't heard of was it Microsoft Learn? Is that
Yeah.
Very cool. I'll have to check that out. So if people would like to follow you specifically, what kind of social media or location, Twitter, where can they do that?
The best way to kind of keep in touch with me is probably on Twitter. I'm under my full name minus the A, so it's Anthony Chu. Because some jerk took my full name and managed to suspend that account. Thanks so much. So that's where most people can get in touch with me. Also LinkedIn and my blog. You just Google my full name. Hopefully you'll find me. Although I tried it yesterday, and you can find this much more handsomer doctor as well. I'm not that guy.
All right. How about do you have any upcoming speaking engagements or anything like that you would like to?
I actually don't have a ton of stuff going on. I have a couple of meetups coming up. I'm hoping to be at Ignite in Orlando in November, and hopefully I'll have a session or two there.
Okay. Very cool.
I'm also hoping to be at Ignite. So We'll see how that goes. All right. Thanks, Anthony. Really appreciate you coming on the show.
Thanks for having me. It was a lot of fun.
That was Anthony Chu. Anthony is a cloud developer advocate at Microsoft in Vancouver, Canada. He's been a software developer and architect for almost 2 decades, currently focusing on serverless, containers, JavaScript, and .NET. At Microsoft, Anthony is helping make Azure an awesome place for developers to deploy their apps in any language and platform.
If you like this episode, please like, rate, and review on iTunes.
Find show notes, blog posts, and more at sixfiguredev.com.
And be sure to follow us on Twitter at sixfiguredev.
This has been another episode of the Six Figure Developer Podcast, helping others reach their potential. I am John Calloway.
I'm Clayton Hunt.
And I'm John Ash.